And next one, it's the advanced system or the advanced simulation. We have a parallel and distributed, and so that we have a high-level architecture. Well, so parallel discrete event simulation. Of course, we will have the simulation executed using multiple processes. So this one, we have multiple processes. And for all the multiple processes, they will run in a parallel manner. Why we want to do so? Because we want to save time. To save time, then we can reduce execution time. So this one, I think you can understand because of saving time. Then we can exploit the parallel simulation. Actually, parallel simulation, this manner employed by the real system, and so that we should have the parallel simulation. Well, to have the parallel manner, then we need to divide the model into several logical processes so that we call LPs. Well, if we have several processes that says LPs here, and then we have a critical issue. We need to determine LP in a proper sequence, and so that we can have the proper event to be processed, and so that we can have the whole response of the system or whole action of the system. Therefore, for this one, of course, we need to determine the LP happen in a proper sequence. Well, so if we have this one, of course, how to have the proper sequence? First one is called conservative. Conservative, actually, we will avoid any violation of local causality constraint. That says event 1 happens and then event 2, and we just follow this, and so that we can avoid any violation of local causality constraint. And later we can check conservative what it means using our keywords. And next one, of course, different from the conservative, we call it is the optimistic. Optimistic, then we will employ the time warp mechanism. Same, later we will check warp. Well, it says we need to still similar to conservative, but we try to employ the time warp mechanism, and so that we can have the approach to fulfill the parallel simulation. Well, so that'll check the 3 keywords in this page. Conservative here, and the optimistic, and the time warp. All right, so about the 3 keywords and key terms allow you to have 1 minute to check. Yeah, maybe just 30 seconds, so let us get back to this. So conservative actually will well preserve the sequence of the events properly. So this is the first one. Optimistic, then we will employ time warp. Time warp actually will change sometime, but far still acceptable. Even it is not the original one, the conservative one. All right, so these are the two types of synchronization in parallel simulation. Of course, if we can do it properly, of course, we will choose the conservative one because that one is the real one, and actually that one can avoid any violations of local causality constraint. However, for some reason, actually, we will refer to the second one that says the optimistic approach by employing the time warp mechanism, so that we still can reach the synchronization in the parallel simulation. Well, this is a kind of simulation, the parallel simulation, and talking about the synchronization. And last one, we have the distributed simulation here, distributed simulation, and so that we will have a different module for the simulation and allow multiple modules to work together. So this way, we will have the distributed manner of simulation, and it's called high-level architecture. So we have the HLA, and because of different module, here we will call federate. Well, we have multiple federates, so we will have the federation. This one, we will have a module 1 here we call federate 1, 2, and 3. And each one can run its own simulation, but we need to allow all the federate work together. So for federate to work together, we will have the runtime infrastructure. So RTI, runtime infrastructure. And the runtime infrastructure, something like this is a common platform for the synchronization. So previously we have the synchronization. Actually for this one, we have the synchronization, but we rely on the common platform runtime infrastructure. Based on the runtime infrastructure, something like we know how to have the proper synchronization among the federates. For example, here we have 3 federates. All right, so this is the high-level architecture with the distributed simulation. And we need to have the simulation in the individual federate, and also we need to have the proper interaction among the federates. So this is the architecture for the distributed one and also the high-level architecture. All right, that's it. So if we want to have a different simulation, we will have this parallel or distributed, and so that we have the high-level architecture. Well, same, we already have the concept. If you want to have the further development, you can try to check all the details for the HLA, and so that you can know how to have the simulation.